Hey guys, and welcome back to another video on the channel. In today's video we're going to be looking at another student question. This one's a vector one. We have done something previous to this on the channel before, but not in terms of this particular setup. I've covered the proof, but let's just get straight into it. So in the diagram to the right, O is the center of a semicircle where A, P, and B, whose diameter is AB. So pretty much we've just got these points here that are on the circumference of the semicircle, whose diameter AB, so that's that diameter there. Let O to A be the vector A, and let O to P be the vector P. That's labeled in the diagram there. The only thing they forgot to do was put in directions, because that'll be pretty important. So what we have is pretty much this setup here. I'm going to draw it a bit better here, just so I can edit it a bit more. So what we have, that's a pretty good, oh, it's like kind of like wonky. Let's try it again. So, yeah, good enough. Alright, so this is B, and this is the point P. This is O. O is the center of the circle. They said that, I think. Yep. And this is A. So this is the vector A, and this is the vector P. Okay. Write OB in terms of A. So what they want is pretty much this vector here. Well, when you think about it, this vector here is just A in the opposite direction, because that's the same length, is it not? So if I were to take this red vector and put it here, it's the same length. The only reason why it's a bit shorter is because I didn't draw it long enough, but it is the same length because that is the radius there, and that's also the radius. It's just in the opposite direction. So the way we'd write O to B is basically just negative A. Now I forgot little arrows on top. You can have the little arrows, but they've got them there. Yeah, same thing. Right, express A to P in turn and B to P in terms of A and P. So A to P, we're going from here to pretty much here, so that vector there. Okay, so don't be confused. That's not the this arc length here. That's not a vector. A vector cannot be curved. It is this bit here. So this vector here is what we're trying to find, and we're also trying to find B to P. So if I move P out the way, this vector here. So this is what we're trying to find. This is B to P, and this here is A to P. So if you want to go from A to P, you need to go from pretty much A to O. So you're going to go back this way, and then plus O to P pretty much. Now, A to O is negative O to A. So in other words, this will be minus A plus P. So we got A to P. Now, if we want to go from B to P, we go from, so we go B to P, we go from B to O, and then we go from O to P. Now, remember, O to B was negative A, but B to O is negative O to B, so that means it would be positive. So in other words, that's actually the same as O to A technically, but you can just write it like this. So it'll be A plus O to P plus P. Righto. So that is that vector there, and that is that vector there. Okay? So that's B, hence prove that APB is 90 degrees. So what we're trying to prove pretty much is, if I rub this out now, is that this is 90 degrees. And that's actually the proof we've actually done previously on the channel. Now, if we want to prove that's 90 degrees, that means we just dot this blue vector with this yellow vector, and if we get 0, it's 90 degrees then. So if we go, alright, A to P plus here, so this is my vector, so if we go B to P dotted with A to P, that's going to be A plus P dotted with negative A plus P. Now, this is going to turn into negative the absolute length of it squared plus the absolute length of this all squared. But this will have a minus because there's a negative component here. So B to P dotted with a to p is the negative length of a all squared plus the length of p all squared. Now, recall, because this is a circle, this length here, the absolute value here, and the absolute value here will be the same length. They'll both be the radius. So these terms cancel out. So you get b to p dotted with a to p equals 0. So therefore, it's perpendicular. Okay? Righto. So that's that question there. And then what circle theorem have we proved? So we've actually just proved this theorem. So if you've got a full circle and you have, let's say, that has to go through the center of the circle though. If you have a line going through the center, let's try and draw a center, and you have these 2 points and you connect it to a point here, this will always be 90 degrees no matter where you place this point. It could be here, and that triangle would be 90 degrees as well. Okay, so that's one of the circle theorems. Nice quick little video. We have done something like this on the channel before. If you want to go check it out, I'll probably link it in the description. But yeah, good question though. Yeah, if you want any more questions, just pretty much just email me and we'll be all good. Alright, I'll see you in the next one.